Students, can you guess what will happen if I leave this bowling ball and feather at one instant? What will happen? Which will fall earlier? We all know that gravity acts same on every object, and ideally, if I throw a egg and a watermelon, now compared to egg, watermelon is massive, right? Its mass is much greater than egg. But still, if I leave both of them at one point of time, you will observe that they fall together. So in this case, what does your logic say? Our logic says that the bowling ball will fall faster because of the shape of the feather. It will tend to fall slower compared to ball. So in this case, our logic says that ball falls faster, it reaches to the ground earlier compared to feather. Let us see what will happen if I leave them together. I will repeat the animation. Yes. Have you seen? Both of them fall together at one instant. Whatever was our logic, but it proved to be wrong in this case. Now, how did this happen? If you do it otherwise in your vicinity, in some ground, you will observe that ball will fall faster compared to feather. Feather will move downwards little slowly compared to ball. Of course, that will happen. But here in this case, it's not happening. Can you guess the reason? Well, that is because this entire chamber has been evacuated. That is, the air from this chamber has been completely removed. And since air is not there, and since there is complete vacuum, both are falling together. So by now you might have guessed what we are going to learn today. Of course, we are going to continue with the lesson gravitation, and today we are going to discuss how to calculate the value of g and motion of objects under the influence of gravitational force. So this is part number 3 of the lesson. In the last session we had learned how did Newton guess the inverse square law. We had learned about Kepler's law, and we had also solved one numerical from the chapter. Of course, we had learned the importance of Newton's law of gravitation and free fall also. So we had learned about free fall also. So these were the topics that were covered in the last session. And today we are going to start with calculation for the value of g. So to calculate the value of g, we should put the values of capital G, which is universal gravitation constant, capital M, that is mass of the planet, and R, which is radial distance, in equation. Small g is equal to capital G into M upon R square. So this equation we are going to use. Of course, we know the values of capital G, which is 6.7 into 10 raised to minus 11 Newton meter square per kg square. Then mass of the earth, which is 6 into 10 raised to 24 kg, and then radius of earth, which is 6.4 into 10 raised to 6 meters. So we are going to replace or put these values in this equation. Now after plugging these values in the above equation, what we get is 6.7 into 10 raised to minus 11 Newton meter square per kg square into 6 into 10 raised to 24 kg divided by 6.4 into 10 raised to 6 meters, and then we have to square it. Now after solving this, the value that I get is 9.8 meters per second square. So this is a value of small g which we get for Earth. On other planets you might get different values. So this is how we calculate the value of g. Now let us move on to the next topic. The topic's name is motion of object under the influence of gravitational force. Let us do an activity to check what happens if we change the shape, size, mass of an object if it falls from a height. Out of which one activity I already showed you in before starting this session. So at the start only I showed you activity. So what we have to do is take a sheet of paper and a stone, drop them simultaneously from first floor of the building. Observe whether both of them reach the ground simultaneously. We see that paper reaches the ground little later than stone. Okay, why? This is also because of the shape of the paper as well as the resistance offered by air. Now you will say, sir, air is everywhere, so it will offer resistance on stone also. But students, the shape of the paper is what really matters here. The material out of which this paper is made and its shape, it is very light, and since because of its flatness, air offers more resistance on this paper. So the resistance of the air depends on shape of the object also. If the shape of the object is flat, then air will offer more resistance. Whereas if the shape of the object is round or like that of the stone, you will observe that it will offer less resistance on stone. So the air offers resistance due to friction to the motion of the falling objects. The resistance offered by air to the paper is more than resistance offered to the stone. If we do the experiment in glass jar from which air has been sucked out, the paper and stone would fall at the same rate. This is what exactly I was trying to show you at the start of the video. Now, we know that an object experiences acceleration during free fall. From the equation small g m upon r square, this acceleration experienced by an object is independent of its mass. So actually if you see, as per mathematical relation, small g, that is acceleration due to gravity, does not depend upon mass of the object. It only depends on mass of the planet. For example, if the experiment is happening on Earth, then it will depend only on mass of the Earth. This means that all objects, hollow or solid, big or small, should fall at the same rate. According to a story, Galileo dropped different objects from the top of Leaning Tower of Pisa in Italy to prove the same. Now, as g is constant near Earth, all the equations for uniformly accelerated motion of objects become valid with acceleration a replaced by g. I hope you remember kinematic equations. So first in the line is v is equal to u plus at. Second equation is s is equal to ut plus half at square. And third is v square is equal to u square plus 2as. Students, these three equations are called as kinematic equations. Now, when object is falling under the influence of gravity, this equation can be modified by replacing A with G. So, V becomes U plus GT. So, instead of A, I will replace small g. सो ए के जगह पे हम स्मॉल जी डालेंगे. ये स्मॉल जी, व्हाट इज दिस स्मॉल जी? स्मॉल जी इज नथिंग बट एक्सेलरेशन ड्यू टू ग्रेविटी. वेल, s is equal to ut plus half at square will become s is equal to ut plus half gt square. So here a has been replaced by g. then v square is equal to u square plus 2as will become v square is equal to u square plus 2gs. Well, I hope you understood how to transform these equations when object is falling under the influence of gravity. The only thing that you have to do is replace A with G. Well, now it's time to solve a numerical. The question is, an object is thrown vertically upwards and rises to a height of 10 meters. So an object is thrown upward and it rises to a height of 10 meters. What we have to do here is calculate the velocity with which object was thrown upward. So first we have to find velocity, and then second we have to find the time taken by the object to reach the highest point. Now to solve this numerical as usual, you have to first arrange the things that you know and then try to analyze how we can find the solution to it or find the answer to it. So the distance traveled has been given, s is equal to 10 meters, and we also know the final velocity because object after reaching to a certain height it is going to 0 over there. Its speed is going to fall down to 0 at a highest point. So v will be, final velocity will be 0 meters per second. Well, distance traveled we know, then final velocity now we know. Acceleration due to gravity, since it is happening on earth, we already know it, 9.8 meters per second square. And since it is going in upward direction, it is going against the gravity. So we have to take minus 9.8 meters per second square. Well, this information we already know now. And since we know these values, we can carry on further by using kinematic equation, which is v square is equal to u square plus 2s. Remember what we have to find. I will show you the question back. I will just go back and show you the question. What we have to find here is velocity while object is moving upward, and then we have to find time taken. So these values we have already know, we have already written, okay, and now we are going to use kinematic equation. What we have to find here? Velocity v. So v is already known, of course, it is 0 meters per second, and u we have to find. So we have to make some adjustments where you will take u square as a known variable, and then you have to replace all other values. So replacing all other values and making some adjustments, you will get minus u square is equal to minus 2 into 9.8 into 10 meters square per second square. So u will come out to be square root of 196 because u square comes out to be 196. So u will be square root of 196, which comes out to be 14 meters per second. So that's how we find the value of u, which is initial velocity. Now to find the time, what I'm going to use is this kinematic equation, v is equal to u plus at, and we have to solve for t. So 0 is equal to, so v as we know it is 0, then u we already know, now we know it is 14 meters per second. Value of a also we know it is 9.8 meters per second square, but we have to take minus sign because it is going against gravity, and then you have to keep t as it is because that is what we have to find. So t will come out to be 1.43 second. So finally what we can say, initial velocity u is 14 meters per second and final velocity and time taken is 1.43 second. Final velocity is 0, of course, because that we already know. So we had to find two things, initial velocity and time taken. So initial velocity comes out to be 14 meters per second and time taken comes out to be 1.43 seconds. So that's how we solve such type of numericals. Well, I hope you understood what I tried to teach you, but if you have any doubts, you can feel free to ask me. Of course, always you are welcome. Now it's time to give you some assignment which you can try out at home. So what do you mean by acceleration due to gravity? That is the question. Then second question is, how do we find value of g? Then third question is, what is the value of g on earth? And fourth question is, state three kinematic equation. Also enlist the modification equations when objects move under the influence of gravity. So kinematic equation, how it changes when the object is falling or when object is moving under the influence of gravity, how those kinematic equation change, that you have to mention. Okay, so these are the 4 questions that you have to solve at home. This is assignment for you. Well, now I should say goodbye to all of you. So thanks for watching this video. See you in next session. Until then, take care. Bye bye.